Alright, so let's wrap up our discussion about trig ratios, okay, by looking at one final situation. And in this situation, what's going to be going on is that our angle is going to be the thing that's missing instead of the side. So in the last examples, we set up our equation. We knew the reference angle, we knew one of the sides, and that let us find the other side, right? So this works out nicely because as long as we know two of those three things, and this, again, in those examples, I knew one angle and one side, I was able to find the third piece of information, which was the other side. I can do that in a different way, and I can say, well, if I know the two things that I know are both of the sides, I can also use that to go backwards and find the angle. So we have to talk about how do we do that, okay? So to find the missing angle, we kind of have to get on the, like in these problems here, we have to get rid of sine so that A is alone, right? If I know these, I can set that up, but then I need sine to go away, or I need cosine to go away, or I need tangent to go away. And so the question is, how do I cancel out the word sine, or the word cosine, or the word tangent? How do I get rid of those operations but not get rid of the angle? And so we have these things called inverse trig ratios, right? Which, if you notice, it's really just the same thing. It's the word sine. To cancel out a sine, I'm going to use the sine with a little -1 next to it, right? And that means inverse sine, or inverse cosine, or inverse tangent, okay? And so just before we get to the actual problems, I'm going to bring up my calculator just so you can see kind of how we're going to handle these. I have these three buttons called sine, cosine, and tangent, and on my particular calculator, I have this INV button, which means inverse. If I click on that, it brings up sine to the -1, cosine to the -1, tangent to the -1, which again, I don't call them to the -1. I call them inverse sine, inverse cosine, and inverse tangent. On most calculators, most standard graphing calculators or scientific calculators, these operations are usually just right above the sine, cosine, and tangent. So usually you'll hit second, and then you'll hit sine, cosine, or tangent, and it will bring up the inverse version, okay? So let's take a look at an example where we might need to use this, okay? So in these particular examples, they're giving us two sides of the triangle. I'm trying to make my calculator go away for just a second, okay? They're giving us two sides of the triangle, and they're asking us what is the measure of angle x to the nearest degree, right? So we're kind of saying, right, that if we set up our trig ratio, what our unknown quantity is going to be is the angle. So let's again figure this out. So if we want to know what x is, we're going to use that as our reference angle, and we're going to label our three sides. So if I say 6 is opposite, okay, bx is adjacent, okay, and 10 is the hypotenuse, it looks like this is an example where I want to use the sine ratio because I don't know adjacent, I know opposite and hypotenuse. So I'm going to set up my equation. The sine of the reference angle, which is our unknown right now, so I'm going to leave that as x, is equal to opposite over hypotenuse, which is 6 over 10. Right? So now I have to solve for x here. And so to solve for x, what we're going to do is we're going to say, I want this to go away. And so the way that I'm going to get that to go away is to apply a sine with the little -1, which we call inverse sine. I'm going to apply this operation to sine because inverse sine and sine cancel each other out, and that will just leave x. So what that means is that I need to apply an inverse sine to this one as well, which I'm going to write as the inverse sine of 6 over 10. Okay? So if you notice, what happened was by applying the inverse sine to the left, I'm also applying the inverse sine to the other side. Okay? And so this is the way I'm actually going to solve this one. I'm going to say if I go to my calculator now, okay, and I type in what is the inverse sine of 6 over 10. Again, make sure you're in degrees mode because they want to know the answer in degrees. All right, I'm going to go to my calculator, okay, and I'm going to type in 6 divided by 10, okay, which is going to give me the decimal version, right? And then I'm going to say I would like to know the inverse sine of that. Okay? And it's telling me about 37 degrees. If I round to the nearest whole degree, x is going to be about 37 degrees. Right? So again, for yours, you might have to type in inverse sine. So hit second, then hit sine to bring up the inverse, and then type in the angle. Every calculator is different on the order that you type things in and where your buttons are. But the concept is that we're going to solve it for x, or solve for the missing angle, whatever they call it, right? And then we are going to get rid of the ratio, the sine or the cosine or the tangent, by using the inverse version. So let's do one more example, right? So again, here's my reference angle x, okay? And if I label my sides, I have opposite, adjacent, and hypotenuse. Okay, and it looks like in this case 15 and 20 are adjacent and hypotenuse, so that is cosine. So I'm going to say the cosine of x, my unknown reference angle, is equal to adjacent over hypotenuse, which is 15 over 20. Okay, to solve for x, I need the word cosine to go away, right? So I'm going to take this entire expression and I'm going to apply the inverse of cosine, okay? And that means that I also need to do that on this side, okay? And so I'll find out that cosine and inverse cosine just cancel each other out. X is equal to cosine with the little -1 symbol, which we call the inverse cosine, okay, of 15 over 20. So let's go to our calculator and figure out what is the inverse cosine of 15 over 20. So again, on my calculator, 15 divided by 20, right? And then I'm going to apply the inverse cosine. And it's telling me, again, rounded to the nearest whole degree, that would be equal to about 41 degrees. Okay. So again, your calculator, the actual solving might be a little bit different on your calculator. So just use your manual or ask, and we shall go through it together.